we just solve only the parabolic arches. So now today we will solve the circular arches and segmental arch. That is our task. Okay, so that's it. A three-hinged semicircular arch has radius r. Okay, has uniformly distributed load, intensity W per meter, acting over length L. Okay, find out the reactions and horizontal reaction also. Horizontal reactions. Okay, that's the task. If you see, it is no need. Okay, that's a good idea, I think. Okay, circular arch. It has also arch hinge. Okay, it's a distributed load of W per meter over the length of L. No L. It's a over the whole length. What is that length? What is that length? What is that length? R. It's a circular, isn't it? It's a circular arch has RS. It's not a segmental. It's a semicircular. So length is 2r. Okay, don't length of 2r. Okay, so length is 2r. That's it, na? That's it. What is the reaction? A and B. How can you calculate it? See, just this A, this A. So what is VA and what is BV? And it's a HA and it's a HB. 4 reactions, 4 equations also. Okay, so you can easily set that VA and VB because it's a symmetrical. So what is the total vertical load? Vertical load intensity W, length is 2r. That is the vertical length is 2r, intensity 2r. So total load is 2WR. So it is equally distributed. So you can easily set W2R divided by 2. So WR, it's a WR. Okay, no problem at all. So what is the horizontal reaction? It is also easily can calculate it because at C, this location is C, moment at C, bending moment at C is 0. Bending moment is 0 na? So just take it VA multiply with R. Okay, so minus H into again R. So this distance also R na? H, and this vertical load, gravitational load, it will goes to moment like this. Okay, so what is that vertical load? So vertical load is W into R. So off length na? Only up to C. So this length is, you know it, R, W into R, and also distance is R by 2. Exactly, that's it, equal to 0 because bending moment at C is 0. So what is that value? You can is the VA is, you know it, WR. So R square, HR WR square by 2 is 0. So what is that? So WR square by 2 is equal to HR. So what is H? RR get cancelled, WR by 2. That's it, na? That's it. So this is a WR. So what is it? WR by 2. This is also WR by 2. HA is equal to HB. No need. Only 2 horizontal reactions are there at A and B. So compulsory there should be equal because no other horizontal reactions are there. Horizontal loads also not there. It's okay. So that's it. you can easily find out. But my task is bending moment, find out any section. To want find out the bending moment at any section, somewhere subset section. Somewhere you want to take it some x distance. If you ask, I ask some x distance, what is the bending moment? What is the bending moment at that location of x? So to find out, you have to find out, first you have to find out this height, this height, na? This height, and also x. So what is that x? X also you can find out. So how they will ask exactly what is the x distance? X distance means, if you see, it is a circular property, na? It is a circular. So circle means, you can see they can ask like this. So at 30 degrees at the radius, at 20 degrees, at 90 degrees, at 90 degrees, they will ask like this. At 20 degrees, they will ask the bending moment. They will ask the bending moment at 20 degrees. 20 degrees from crown to that location. Maybe this is the theta, this is also theta, na? So that's why you have to mention from which side. So the bending moment at that location, what is that location? Location is 20 degrees from the crown. What is that value? What is the bending moment? Someone asked like this. Someone asked like this. So because it is a circle, na? Circle. So circle has a radians, degrees. These are the properties. They won't ask like 2 meters from support A, 3 meters from support A. No, they will ask like that because it's a circle. So okay. So if someone asks some theta, someone asks like this theta, how can you find out? Okay, so you can easily find out, you can easily place it the x in terms of theta. You can easily get it. See it is. So what is that value? What is the bending moment? What is the bending moment at 20 degrees, 20 degrees from the crown to that location? So not a 20, now it is a theta. Theta degrees from crown to that location. Okay, see it is. What is the bending moment? So if you want to bending moment, you want to find out this x and this also y. Okay, you want to find out that x and y. So those are the locations. You see it is, see it is, you can find, you can place like this, you can place like this. Okay, are understood? So now my intention is bending moment at the theta location. What is the theta location? See, that is theta location, this list. Okay, that is the location. If you see, how can you write it? Va multiply with x, na? Va multiply with x distance. Okay, h multiply with y, h multiply with y. And so this vertical load, what is that vertical load? What is that vertical load? Vertical load is w, acting is x distance, na? X distance on x by 2. That is the bending moment. That's na? That is the bending moment. But you can write x and y in terms of theta because he asks some theta degrees. He asks some theta in circular property. So how can you write it? How can you write it? How can you write it? See, exactly, if you see it is, if you see this triangle, if you see the triangle, okay, this height, this distance is what? This distance is what? This is r. Circle, na? Circle, anywhere is r. Anywhere is r. Okay, anywhere is r. So r. So if you see this, see it is. What is the distance? This distance is what? That distance is what? R sine theta. Okay, or sine theta. That's it, na? If you take that, otherwise if you take the triangle, so if it is called some z, so sine theta is what? Z by r. So z is r sine theta. So that's it, na? This is a z or sine theta. If you taken this height, what is that height? That height exactly equals to y. Understood? That height exactly equals to y. So if you take in cos theta is y by r. That is a cos theta. So y is r cos theta. Are understood? So what is x? What is x? This total height is also, this total distance is also r. But you know what is z? Z is, this distance is z. Z. So what is x? X is r minus z. So what is x? R minus r sin theta. That is r multiplied with 1 minus sin theta. So that's the way you can calculate any height and distance. It's not a parabolic, it's a circular arch. Okay, so now you can take it. Now you can take it. So bending moment at that location is what? VA is what? VA is what? We already know what is the VA. VA is WR. Okay, VA is WR. What is X? X is R 1 minus sin theta. X is R 1 minus sin theta. And H is what? WR by 2. H is what? WR by 2. Y is what? Y is R cos theta minus W. X is R1 minus cos theta. Again it's R1 minus cos theta divided by 2. That is the bending moment at that location. So that is the bending moment at that location. If you see W R square 1 minus sin theta, sorry, it's a cos theta is not 1 minus sin theta. Okay, 1 minus sin theta. X is R into 1 minus sin theta. Okay, multiply with W R square by 2 cos theta. What is this value? This value is W R square by 2 1 minus sin theta whole square. Are understood? 1 minus sin theta whole square. That's it, na? That's it. If you want to solve it, just solve it. Solve that location. Solve that. Can you solve it? Can you solve it? See, I will solve it. I will solve it. I will solve it. WR square by 2, you have to take it outside. So you have to take it outside. 2 minus 2 sin theta minus, it's a cos theta minus 1 minus sin theta whole square. That's it, na? So that's it. WR square by 2. So 2 sin theta minus cos theta minus 1. Okay, so again minus sin square theta. Okay, minus plus 2 sin theta. That's it, na? So 2 minus 1 1. So 2 sin theta gets cancelled. Okay, what will remaining? WR square by theta. So 1 minus cos theta minus sin square theta. Okay, WR by 2 1 minus cos theta sin square theta. That's it, na? That's the bending moment. That's the bending moment. You can do, if you given the value, it is very simple. Without giving the value, I will give it like this. So now my question is, where the bending moment is maximum? Where the bending moment is maximum? So this is a bending moment, na? At that location of theta. Somewhere any theta, you can easily get it. If you know theta. So okay. So where is the bending moment maximum? How can you find out? So bending moment is maximum, he asked. You can easily set that at that location of the bending moment. If bending moment is maximum, shear is either shear force is either maximum or minimum. That's it, na? So you can set that where the bending moment is maximum, the differentiation of bending moment with respect to theta, these all quantities in theta not x, is going to be 0. That's it, na? So with respect to theta, differentiation of bending moment means what? Shear force. Shear force is compulsory turn into 0. If shear force is reaches to once, if you see it is loading, this is a bending moment maximum. If you draw a shear force diagram, how It reaches na, so compulsory it reaches to 0, it turns to 0, so the differentiation should be minimum. This is equal to 0. Understood? So you already know from your school level onwards you have to do like these problems. Okay, so now where the maximum bending moment, you see differentiation, do differentiation. W r square by 2, 1 is 0, so minus cos theta sin theta, so sin square theta 2 sin theta cos theta. So okay, so if you find out it is equal to 0, it will goes like this. Sin theta you took constant, sin theta 1 minus cos theta equal to 0. That's it. Sin theta 1 minus cos theta equal to 0. So where is the theta? What is theta? So if it is 0, compulsory either sin theta equal to 0 or 1 minus cos theta equal to 0. That's it. So if sin theta equal to 0, theta is 0, 180. We already know it. Theta equal to 0 means what? Theta equal to 0 means crown point. Theta equal to 0 means what? Crown point. We already know crown point is 0. No need at all. Crown point is 0. That is not a maximum. It's a minimum. 0. But some other place. So we already know that location. So we delete it. So 1 minus cos theta equal to 0 means what? 1 minus cos theta? No. 1 minus 2 cos theta. Alright. 1 minus 2 cos theta. 1 minus 2 cos theta. Okay. So 1 minus 2 cos theta is 0 means what is that? 1 by 2 is equal to cos theta. That's it. So what is the cos theta? Theta is what? Theta is 60 degrees. 1 by 2 where? Where is the 1 by 2? Where is the 1 by 2? So exactly 60 degrees. That's it. So at 60 degrees, max bending moment is maximum. Okay, bending moment is maximum. That means what? That means what? At 60 degrees somewhere, I think. At 60 degrees from the crown position. Otherwise, from this position, it's a 30 degrees. At 30 degrees, the bending moment is maximum. Are understood? So bending moment is maximum. So what is that maximum bending moment? I am again asking what is that bending moment is maximum. So again you can do that. So this is a bending moment. Na? Put maximum bending moment, otherwise 60 degrees. So put theta is 60. What is that value? W r square by 2, 1 minus cos 60, 1 by 2, sin 60, 1 by root 2, root 3 by 2. So square. So how will get? How much you will get? You will get W r square by 8 minus, you will get W r square by 8. Understood? W r square by 8. Okay? W r square by 8. Okay? That's it. Bending moment is maximum. If you draw bending moment diagram, if you draw bending moment diagram, I will show you. If you draw bending moment diagram, is 0. So if you draw bending moment diagram, it will give like this shape. This shape. So exactly I will draw it like, it will give like this. Okay, so if you took, that's so exactly 60 degrees from that position. Otherwise it here also 60 degrees from crown or 30 degrees from this location. It will go maximum bending moment. Okay, maximum bending moment. So what is that bending moment? WL square by 8. WR square by 8. Okay, so that's the story. Okay, So that's the end of the story. So I am asking, I will give the one question example assignment. Okay, took this is a semicircular. Okay, no need to draw. Okay, semicircular. So radius is, I will give the radius is 30 meters. 30 meters. This is the load of 10 intensity, 10 intensity, and I will took, this is a point load of 50 kilonewtons, 50 kilonewtons. Okay, so acting acting at acting at 60 degrees from basement. Okay, so this is the assignment. So you have to find out the bending vertical forces, vertical reactions. You can easily calculate it. This is also hinge. Okay, so I want bending moment at that location of, now I will ask 45 degrees. So you can easily find out this distance. Otherwise if you find out the reactions, it's easy. Reactions, it is very easy. Okay, no problem at all. So I want bending moment at the location of 45 degrees, 45 degrees from crown or otherwise support A. Okay, find out the bending moment at the location and also find out the vertical reactions and horizontal reactions. Okay, vertical reaction, horizontal reactions. Okay, that's your task. So you know how to take x and y. That's it. Okay, that's it now. That's the story. That's the story of circular arches. And you can easily find out at that location what is the normal shear or normal shear and radial shear also. You can easily find out now. You can easily find out, no problem at all. So if you take it this location, if you see, it is at that location. If you want to find out the normal shear, that's it. So it has some load, it is horizontal, it is vertical. So it is horizontal, it will get horizontal. Vertical, if it is some 30, what is that exact this load? It may be 20, it will come like it's a 20. So you will get this and you will get this, not this. Okay, so what is the theta? What is the theta? Theta has doubt na? Theta has a doubt. So you will get easily see it is, if it is theta, what is the theta? This is 90 na? This is 90. This is 90, but exactly if you take horizontal, if you see it, take a horizontal, if it is taken horizontal at this low crown location, this is a horizontal, this is a horizontal, it's a 0. It is it, it is see, it's a 90. So it is get 45 degrees only. So that theta is 45 only. I understood. It's a 45 only. I understood. If you at this location, 0 location, if you see, it's exactly 90. 90. So what is the angle? That is the angle here. If you see, I asked some 30 degrees, some this location. If it is this is the location, it has 60 degrees. What is the theta? What is the theta? Theta is 60 only. So no need to find out the extra. So exactly where you are asking what is the theta is? Theta is 60 from crown. I understood exactly this theta is 90, this theta is 0. So no need to find out the theta. So because if you see in parabolic arch, the slope is changing. And we have a parabolic equation. By this equation, we will get the what is exactly the theta. But we know it exactly, it is a 90, it's a 0. From horizontal, from the horizontal point of view, it's a 90, it's a 0. So what is that value? We will get what is the angle taking or what is the angle so making. It is the angle. So okay, so now I am asking, I will add that question. So you want to find out that location, normal shear and radial shear also. You will get it. You want to find out? Yes, I want I want to find out, find it. Okay, that's your assignment. That's the task. Semicircular arch, you will get anything, no problem. Now we will do another problem. Now we will today, not today, next our topic is, we will solve one problem regarding segmental arch. Okay, segmental arch. Now we will took the segmental arch problem. Segmental arch problem. Okay, so see, a three hinged circular arch or segmental arch hinged hinged, okay, has a span of 40 meters. He gave the span. If you given the span, that means it's a segmental. Otherwise, if you give a radius, like radius, you will easily get it as a semicircular arch. He said that it's a span of 40 meters and rise of 8 meters. It carries a UDL of 20 kilonewton per meter over the left half. And a concentrated load of 40, it's 100 kilonewton at right quarter span. Okay, so find reactions on shear at 10 meters from left. Shear means not a normal shear, so you have to find out the normal and radial shear also. Okay, see this, we will draw a picture. If you draw a picture, it completes half of the problem. That's the meaning. Okay, I will draw a figure. Okay, so I will cut a segmental. Okay, it's not a full circle, it's a segmental. Are understood? It's a segmental. It's not a semicircular, it's a segmental arch. Okay, segmental arch. Okay, I think that's only better. Okay, what he said is span is what? Span 40 meters. Span 40 meters is 20 meters. It's a 20 meters. So rise of 8 meters. See, it is rise of 8 meters. So it's a only segmental arch. Okay. So it's like this. It carries a uniformly distributed only left span. Okay, left span. What is that height? It's a 20 kilonewton per meter, and has a point load of concentrated of 100 kilometer at quarter span under. So quarter span means it's a 20, it's a 100. Okay, so exactly quarter means, he said that it's a 10 meters. So 100 is acting. So what he wants reactions A, B, and also it's a C is also hinge. Okay, so reactions and bending moment at 10 millimeters from left. So bending moment, he asked again, it's 10 meters. He wants bending moment at this location. Okay, bending moment at that location, and also shear. Okay, you can easily find out. See, you can easily find out. Okay, so what you can do, so see VA, it's VA and VB. VA plus VB is what? Total what? So 20, it's a 20, it's a 400. It's a 400, it's a 100. So VA VB is 500. You know, it VA VB is 500. So now you take a moment at A. Moment at A. Moment at A is 0. We will take moment at A. Bending moment also 0, but we will take from one side. Na? So one side, other side is there is no nothing is there. A is a hinge joint, moment is 0. So take A with respect to A. What will happen? VB into 40. VB multiply with 40. So next 100 multiply with 30. That's it. Now this is also 10. 100 multiply with 20. So next what happened? So this point load, this uniformly distributed load. What is that uniformly distributed load? 200, not 200, 20 multiply with 20. So 400 is the load and acting at 10 meters. That's it, na? Is equal to 0. So what will happen? VB 40, it's a 3,400 into 4,000. So okay, 4,000. So VB 40 is equal to 7,000. So VB is equal to what? 7,000 divided by 7,000 divided by 40. What is that value? $175. Okay, it's a 175. So if it is 175, what is the VB? VA? VA is what? 500 minus answer. It's 325. That's VA VB. Okay. So that's it. As usual, what you did in a strength of materials first. No interest on HB, HB. Big C. Chapman, madam. HB into C. Perpendicular distance is what? 0. It will directly pass through the VA. It directly pass to the joint of A. Are understood? VHB directly pass to the point of V joint A. What is the distance? 0. Madam, HB load is passing through that joint only. So that is important. That is easier task in the arches. See, there is no importance of HA and HB because if you take in the moment at A, if you take a moment at A with respect to A or with respect to B, the other joint horizontal force directly pass through that point, because so you can't take it. So you can easily find it. But if you see for the last class you took it. For the last class, if you take it, this type of differential elevation, if you take it, that is, so if you take a moment at with respect to B with respect to A, the horizontal reaction at that location not directly pass through that point. It has some differential elevation is there. Are understood? So that's why are understood. Last class I said that. So I will give, see the value. I will give that value, height 2 meters. If they are both on same level, you can't take it that in account, because the load directly pass through that point, pass through that joint. There is no movement generated with respect to that point. Okay, so that's it. Where is that? So that's it. VA and VB, we got it. So once you know VA VB, you will easily got HB, because so you can take its moment with respect to C. Bending moment at C is 0, because it's also a crown joint, crown point. Na? Crown point. Take it from right side or take it from left side. Take it from right side or take it from left side. You will get it. What you get? You will get HA and HB. See, from left side, from right side, I will took right side. So what will VB multiply with 20? VB multiply with my 20 minus HB height is 8. HB multiply with height is 8. That's it, na? So now also minus of 100 multiplied with distance is perpendicular distance is 10 equal to 0. So VB is what? VB is 175. 175 20 minus 1000 is equal to 8 HB. Okay, HB is what? 175 multiplied with 20, answer minus 1000, answer divided by 8. It's a 312.5. So HB is 312.5. HA is also there because there is those two only horizontal reactions and there is no other horizontal loading is there. Okay, HA is also 312.5 kilonewtons. Once you got it, so you got it. So now what is the bending moment? What is the bending moment at that location? So what he said that shear at 10 meters. So it is a 10 meters. So it is a 10 meters. He asked directly from 10 meters from left support, but I ask so 20 degrees, 20 degrees with respect to the crown, with respect to the crown. So the position of that section makes an angle of 20 degrees with respect to the crown. I ask same like arch. It is also arch. It is also arch, na? It's not arch. It's also circular, na? But I will ask 20 degrees. What we will do? Again, later part I will set. He asks directly, but it is easy. But I will ask 20 degrees with making of angle with respect to the crown or with respect to the support A. If you support A, you will take like this, or you making 20 degrees with respect to the crown, you will take like other thing. Okay, so I will later I will show you. First you should take this is the XX section. So what is the bending moment? Directly you can write it. Bending moment at section 10. VA multiply with 10. 10 na? VA multiply with 10. VA multiply with 10 and H multiply with this height. You want this height, na? You want this height. So that height I call as Y. So HA multiply with Y, perpendicular distance. Okay, Y. So and also this 20 up to what? 20 into 10. That's the load, na? So that's the load of 20 into 10. Distance is 5. Central distance is 5. That's it, na? It will 5. So is equal to the bending moment. So what is Y? How can you find out Y? How can you find out Y? So how can you find out Y? So that is our task. So if it is, see, it is a segmental arch. It is a segmental arch. First we have to find out the what is exactly the arch center. Maybe I'll take this is a center. Segmental arch, na? It's not in a center here. It's center somewhere below. Segmental arch. So see segmental arch. Segmental arch property. So that's it. That's if you taken this is the angle or with respect to this value or with respect to support A or with respect to support Q. Later we will discuss. Okay, first you have to find out what is R. What is R? So I already said circular property. I already said what is the circular property? Segmental arch property. If it is a circular segmental, if it is L by 2 or it's L by 2, it is H. It is what? It is 2R minus H. That is the diameter. So I already said L by 2 multiplied with L by 2 is equal to H into 2R minus H. Those are the proper multiplication will equal. So now you see it is a 10, it is a 20, it's a 20. Those two distances are what? It's a 20, it's a 20. H is rise is 8. 2R minus 8. So you will get R. So what is R? What is R? So 20 divided by 8 plus 8 whole divided by 2, you will get R. So what is R? R is 29 meters. R is 29 meters. So okay, R is 29 meters. Okay, R is 29 meters. R is 29 meters. Don't care. So okay, what is okay? R is 29 meters. That's it, na? If you see now, I will see. I will give the properties here. So this is something. This is 20. This is 20. I will ask this. This is theta. That is theta. Something theta. We don't know. We don't know that theta. So if it t, what is the theta? This theta is also, that theta is also 29 degrees. We already discussed later. Not a theta. Oh, sorry. So 29 degrees is not this. Okay. This is theta. Okay. Say okay. No problem. No problem at all. See. If now see. So now you have to observe how to calculate x and y. Okay. So since this is one distance y, this is another distance of x. How to calculate x and y with respect to theta? How to calculate x and y with respect to theta? Okay. So see it is. So what is next? Exactly. We already know. We already know theta. We already know. So no. So see it is. This total distance is something called L by 2. This is also called L by 2. You call it as L by 2. Okay. So what is x? Exactly what is x? X by 2. So see it is L by 2 r minus L by 2. See, so what is not? Okay. See it is. See it is. What is x? Exactly if you get this value, if you know this value, exactly L by 2 minus that value is some z, I call it as z, you will get x. So what is that value? What is that value means? Exactly this is means this height, na? This distance. So what is the distance? The distance is r cos theta. So cos theta, no, sin theta. The distance is r sin theta, na? See it is. This is theta. This is r. What is this value? This value is r sin theta. Just now we discussed it. So exactly what is x6? L by 2 minus r sin theta. That's it. You will get it. We already know this is 10 meters. We already know that is 10 meters. That is not a particular meter. If I ask bending moment, that location, the location is at 20 degrees from the crown. 20 degrees from crown. You will get x like this. You will get x like this. First you have to find out that what is a L by 2. So we already know L by 2. So we know the L by 2. So remaining is x is L by 2 minus r minus cos theta. Not r minus r cos theta, because see previously it is a semicircular. Now it is a segmental. So it's a total distance from the joint A to joint C is not in r. It's L by 2. Okay. So later, what is y? Y is exactly, this is the y. Okay. First I will see. First I will see. See, like this. The total height is r. It's r. And if you see, this height is, that is a rise. What is rise? Okay. I will delete this value. I will delete this value. This value. I will delete it. Only I'm interested in this value. So what is that value? So total r minus rise. What is rise? Rise is h. H taken as a rise. R minus h is, you will get this value. That is the value, na? R minus rise, you will get this value. Okay, side it. Keep it aside. Okay, so keep it aside. Now you took the same triangle here. What is this value? This value is r cos theta. Okay, r cos theta. If now you see, this value is r cos theta. In this r cos theta, you delete this value. If you delete this value, you will get exactly what you want, this value. this is equal to y. Okay, delete this value, that value is r minus h. So now you will get easily that y is equal to r cos theta minus r minus h. That's it, na? That's it. So that's the theory. That's the theory. You can write it like minus minus h minus r 1 minus cos theta. That is a y. If you know this is a y value. Understood? So that's why you can find out x and y. From previous edition, it's a semicircular. You will get x and y easily. But if you give a semi-segmental arch, you will get x and y like this. Okay, so that's the difference. That is the difference between those two. Now it already given 10 meters. So by this 10 meters, you will get theta. So based on theta, you will get y. Understood? So we already said that it is like 10 meters. So what is y? So if you know the y value, you will easily get that bending moment. Understood? That's the theory, na? That's theory. So he asked 10 meters from support. Maybe I will ask the bending moment at section. The section lies at 20. Section is making 20 degrees with respect to the crown, or 70 degrees with respect to the support A, or 70 degrees with respect to the support A. Both are equal. Okay, so like this you will get x and y. Okay, so this is also assignment. Find out the y value and find out the bending moment. I want the bending moment answer. Okay, we already given 10 meters. L by 2 no, r no. What is the find out the theta? So later you place theta here, you will get y. You will find out the bending moment. So because the time is already over, no need to calculate the bending moment. So now I will explain shear calculation at that location. This is the location. What is that location? Theta. If you to draw a tangent here and a straight line here and a straight line here, what is the theta? Theta is same this theta. Are understood? Theta is same the theta. Are understood? So what is the theta? What is this theta? What is the theta? I am asking theta. I am asking the theta. Okay. See what is, how can you find out theta? So already find out. So you will find out theta like here. You will find out the theta like here. Okay, can you find out? Can you find out the theta here like this? So see, so some advantage here. We already know. See, it is a 10 meters. X is a 10 meters. What is this remaining value? Remaining value also 10 meters, na? Remaining value is also 10 meters. It is, we have an advantage. So what is the meaning of r sin theta? R sin theta is 10 meters, na? No need to calculate. So you can easily calculate theta from here. Example. So we already know x is 10 meters. Remaining segment is 10 meters. That remaining value is na r sin theta. So you will get this is also 10 meters. So r by L by 2. L by 2 is 20. 20 minus 10, 10. We already know it. So you can easily find out theta here. R sin theta is 10. You will get what is theta? Sin theta is 10 by r is what? R is what? What we find out? Where we find out? Where is r? R is 29 meters. R is 29 meters. Theta is sin inverse of 10 by 29. What is that value? What is that value? 20 degrees 17 minutes. So, okay, that is the theta value. You can easily find out that value. So r sin theta is also 10 meters. Okay. Otherwise you will find out theta from this equation also. Because see, it is L minus 2 is 20. 20 minus 10, 10. You will get r sin theta is 10. By looking, you can set it r sin theta is 10. Otherwise, see this equation also, you will get r sin theta is 10. So once you got the theta, see, now I will draw a semi-segmental arch. So okay, it looks like a segment. Okay, don't take it as personal. I will take it. This is arch. Okay, this is that's exactly the section. That section is 10 meters, and this C, this normal direction, and it's a horizontal. Its theta is 20 degrees. Theta is 20, and the C, it has uniformly distributed load of what is intensity is what? Intensity of 20. Okay, it's at 20, and vertical reaction is VA is what? What VA? VA is 325. This is 325, and H is what? H is what? 312.5. H is 312.5. This is 325. Okay, this is 312.5. So okay, now you see, should be placed like first you should be placed this segment is in equilibrium. So this segment equilibrium means you have to find out first shear force. What is shear force? If you see, this is 20, this is 10 meters, this is what is total load is 200, but if you see from bottom it will come at 325. That means what should be equal? It's a 125. It's what? It's a 125, and should be equal. This is a 312.5 compulsory. This is also 312.5. Now it is an equilibrium. Shear force is 125. You know it is shear force is 125. So horizontal reaction multiply with minus of vertical reaction, you will get shear force. But I want asking of normal shear and radial shear. Normal shear and radial shear. If you see, this is a normal shear. What is that? This is the radial shear. This is N, this is Q. Okay, you will easily get it, no problem at all. See, what is the normal shear? What is normal shear now? Normal. So 312. So theta na. So see, it is 312 cos theta. 312 cos theta. It's a cos theta na. So that's it, cos theta, and also 125 sin theta. Same direction na. 125 sin theta. If you take is Q, if it is Q direction, so Q direction, see, so 312 it will goes to up direction, but it's, I said I draw as Q is in down direction. Understood? This vertical contribution goes to this direction, not a down direction. So that's why I will give negative 312. Now it's a 312 sin theta, but if you see 125 in this direction, it will give same direction, so positive. 125 cos theta. That's it. This is a normal shear, this is a radial shear. What we drawn in the direction. If I get the Q value negative, that means what? Q is not in that direction, it will go to opposite direction. So what is the N value? So N value is 336.43 kilonewtons. Q value is 9.57. Mostly, if you see, Q is one value positive, one value negative, most probably. So that's why it goes to be minimum value. Radial shear is minimum. If radial shear is higher, it will shrink. You already know cylinders. So no, thick cylinders, thin cylinders. What is the radial stress? Radial stress, normal stress. You know it, na? So it is a cylinder is there. So normal stress is a radial stress. Otherwise radial stress. Okay, radial direction, normal direction. So that's it. That's the end of the story. Okay, so you will solve any type of problem now. 3 hinged arches, you will solve parabolic arch, you can solve symmetrical arch, semicircular arch, or you will solve segmental arch. So how to find out X and Y, I will explain here. Arches and semi-segmental arch. So parabolic arch also. Now you can solve any problem and you can find out the bending moment at any section. And also you can find out the normal shear and radial shear. That's the end of the story of 3 hinged arches moment shear force calculations. But one thing is remaining. What is that remaining is temperatural stresses. If the temperature is rising, temperatural stresses. What will happen? We will discuss tomorrow. We will discuss tomorrow morning what is the temperatural stresses, how do we solve the temperatural stresses. That's the task of tomorrow. And we will give the introduction of two hinged arches also. It's a two hinged arch is somewhat lengthy. Okay, total classes assigned for the arches is 8 classes. I think it's the fifth class, I think now. No, it's the fourth class. Fifth class is also assigned for the three hinged arches. With 3 classes, how can I solve? How can I complete 2 hinged arches? Okay, no problem. Okay, so feel tomorrow we will discuss temperature arches. So today class is over.